Hey guys, this is a small project I think you'll enjoy. You guys out there with Myford lathes might find it of particular interest. This is a Hemingway travelling steady kit. In this case, you're basically buying a casting, and the small blanks of steel save having to go out and find your own. The casting is adequate, a little rough around the edges, and there is a big inclusion in one corner. That's the first thing we'll deal with. The aluminium filler rod I'm using is called Durafix. It melts at a much lower temperature than proper aluminium filler rod. There are a few brands out there of pretty much the same stuff. Just Google something like low temp aluminium brazing. Just like soldering, the trick is to heat the part and not just melt the filler rod on top. Okay, first machining task. The plans ask for a flat machined datum face. All of these Hemingway kits are supposed to be doable on a Myford with a milling attachment. I couldn't figure out a way to clean up a face this size on the Myford. It might be possible to mount the part onto a faceplate somehow, but I decided to just lap it smooth with sandpaper. Next, I just roughly level off the base, enough to have a flat surface to work from. When we're done, this is where it will mount to the lathe. So now we'll surface the faces that sit up against the cross slide. I couldn't think of a good way to set the center point for both the vertical and horizontal slides mechanically, so I scanned and printed the outline to scale. And superglued to the casting. I'll use this to set the part up for subsequent machining. There is plenty of excess material to be removed from the base. This is where the milling attachment becomes a limitation. There is no easy way to mount the casting so that both faces can be cut in one setup. I guess using a square is good enough, and I lapped the surfaces with sandpaper on a flat surface afterwards. Now I'm setting up to drill the hole for the mounting screw. I just aligned the printout with the centre of the lathe, and then marked with a pen where the steady sat, and using measurements transferred that spot onto the steady itself for drilling. Next, it's time to machine the slot for the horizontal slide. I'm using an 8mm high-speed steel end mill, taking 0.5mm deep passes. A 0.5mm cut is about all I'm comfortable with on the milling attachment. There is a huge cantilever off the cross slide, which isn't exactly heavy metal itself. It doesn't take much for an end mill to dig in. And while the part is set up, I started the through holes with an undersides bit. I obviously don't want to drill all the way through into the milling attachment, and this way I can get the holes bang in the centre of the slot and just finish them to size later on the drill press. I used the printout to align the second slot on centre. Not ideal, but hopefully it will be good enough. And there we go. That's the slots finished. Now check out this precarious setup. I could have just fired a drill through by hand or in the drill press, but I really wanted to get the holes as aligned as possible. You can see that because of the size of the part, anything that has to be machined on centre is going to push the casting hard down against the bed of the lathe. Anyway, gentle drilling went okay, no problem. That's all the machining on the casting itself. From here on, the parts are smaller and therefore much easier to deal with on the Myford. For the slots in the brass, I started with a drill bit just under 8mm. I can't remember the exact size, whatever I pulled out of the inch set. Then plunged in with an 8mm end mill. You can see I have aluminium packing behind, so I can push right through. Now I can run the end mill back and forth, and on the very last pass I scraped it right into the ends. That created a perfect 8mm slot, but I stuffed up the centering and had to slightly enlarge the slot anyway. Turned out okay though. I intentionally left the slots slightly undersized. I'll draw file the brass down to fit. I'm a fan of a filed finish. I'm a little tired of hacksawing everything. I have this rear tool post that came with the Super 7. I had been using a parting blade in its own holder, the type that clamps under the normal tool post, but they really suck. So I finally got around to grinding a parting blade from tool steel and making the little wedge that was missing. She's a little chattery this far out from the chuck. As the cut went further in, things smoothed out. I did the next cut in back gear mode, which was much smoother. This is the through bolt that holds the brass slides. I won't be knurling the heads of the screws or lock nuts right now because I don't have a knurling tool. I could just buy a cheap knurling tool and get the job done, but I'd like to make my own tool in the very near future, so that would be a bit of a waste. I don't really like buying cheap junk that I know I'm not going to end up using. The last thing to do is clean up the rougher parts of the casting. The casting will ultimately be painted, so I'm not too worried about it, but I knocked off the worst of the seams. I do have some of the paint left over from the ML7, but I'd like to save that for touch-ups. This steady will stay with the Super 7, so I'll paint the steady alongside the Super 7 project when we get to that. And that's about it. So this kit was a little bit of a hassle to get done only using the Myford, but I managed okay in the end. On a proper milling machine it would be simple. The main hassle was resetting the milling attachment for the only possible arrangement that would work for the next cut, so the project took a while. The kit costs about what you'll pay for an Indian knockoff or second-hand original travelling steady. But the end result is more functional than the original Myford version because of the adjusting screws. And hey, we all enjoy projects in the shed.